Hello and welcome back to my channel. This is the continuation of my previous video where I attempted to fix this Apple IIc computer. Now if you haven't watched that video, I would definitely recommend you go and watch it because lots of things happen in that video. I started with a memory problem, then we had a power supply problem, then we had a floppy drive problem, and we fixed everything and the computer was working perfectly fine. And just at the end of the video, the floppy drive failed again. So I decided just to split the video in two because otherwise it was getting too long. So on today's video, we're gonna pick up from where we left it. So I'm gonna work on that floppy drive problem. At least I think it's a floppy drive problem. And hopefully by the end of the video, we are gonna have a fully working Apple IIc with no further surprises, I hope. But enough with me talking, let's start working on the floppy drive of this Apple IIc. This video is sponsored by PCBWay, my supplier of choice for PCBs and 3D prints. So the first test I'd like to do is there any data coming out of the drive? Because now we're talking about reading. Writing is not involved at this stage, it's just trying to boot up. So I've got test point 1 here, and what I'm gonna do, I'm gonna restart the drive, restart the Apple IIc while probing this test point 1. Let's have a look in 3, 2, 1, go. I do see data. That, to be honest, it looks pretty healthy to me. It's 5 volts. It's moving, it's doing stuff, so it looks like the drive is actually reading something. Now I would say let's cheat the system a bit at this point. I'd like to try and replace the read amplifier from the Apple IIc drive and see if that changes anything. Okay, I've got the read amplifier from the other drive. Let's see whether that changes anything here. No, and it doesn't change anything. I still have checked this drive. Let's move these two ICs to the Apple IIe drive and let's try the Apple IIe drive on the Apple IIc. I guess this way in one go, I can test these two ICs and also making sure that the issue is not with the Apple IIc and it's with the drive itself. Okay, I've got the Apple II drive connected with the ICs, at least the two socketed IC coming from the Apple IIc. Let's power up now. It is working, and this is the same floppy drive I was testing a moment ago on the Apple IIc. So this is telling me these two ICs are working. Well, at least the reading one, and the write, to be honest, when it's booting up, I don't think it's doing anything, but at least we know the IC is not like shorting stuff or anything else. We know that the Apple IIc is working and also that the floppy disk is working. So 100% the issue is with the drive. Did you notice anything? I mixed up the ICs. The one with the label on top is the one which I pulled from the 2E drive to test on the 2C. And then I moved it back to the 2E drive thinking it was the suspected one from the 2C. But no, that was the known good IC. No wonder that worked. And just as a fun thing I've just discovered, I'm trying now the Apple IIe drive, but I guess the 2C is going to be exactly the same, without the write amp IC. But when you're booting up, really, there shouldn't be any need to write anything on the disk. And if I boot up, it does work. So, so obviously this is not a writing issue because again the drive doesn't care about the writing circuitry when it's just a matter of booting up the floppy drive. Now this might suggest that there is an alignment problem with this drive, which honestly again I don't understand how this could have happened, but I can't discard anything at this time being. So what I'd like to do, I'd like to install this drive on the Apple IIe because the Apple IIe can install two drives at the same time. On the C it's a bit complicated, so I think I'll use the Apple IIe with my working Apple IIe drive and this drive here. So the Apple IIe is going to be the primary drive where I can boot some diagnostic software, and the Apple IIc is going to be the secondary drive so I can tell the software, can you go and test drive number 2? Because what I think I'd like to try is, besides looking at what the diagnostic software is telling me, chances are that if I copy a floppy disk from a working Apple IIe drive to this drive, you will copy and then it will work. And that hopefully will tell me that the drive is working, it just has been misaligned for whatever reason. If not, we'll move from there, but that's what I can think at the moment. Okay, I'm ready to try. I've got XPS diagnostic, which is my favorite diagnostic, and also I know that it can test the other drive. So let's power up in 3, 2, 1, go. Okay, XPS is running. So the first thing I want to do is to change the slot and drive, which is F. It's going to be slot 6, drive 2. Perfect. Yes, it's correct. Now let's, for example, try and check the speed, H, and it should run on the Apple IIc drive. Yeah, it is running, but it's unfortunately it's not reading any speed at all. Oh, and XPS has, let's say, crashed because it's not responding anymore. Perfect. That's not a great start. So let's try with the disk system test. G. Okay, well, the drive is showing all sort of errors. We got speed errors, we got seek errors and read errors, everything. Now, I'm not entirely sure whether XPS is expecting a formatted media. I believe so. So before doing that, what I'd like to try, I'd like to run Locksmith and just copy any disk, to be honest, to drive 2. At that point, when we're testing, XPS will find the drive which has been formatted with this very drive, in case this is just an alignment problem. But I'd like to say the good news is the drive is not dead. I mean, the head is moving and it's trying to do something, it's responding to the system. So hopefully, finger crossed, it's nothing major. Right, I got Locksmith in the drive, so let's run it. What I'd like to try now is to copy something from this working drive to the Apple IIc drive. I'll just put Frogger in the Apple IIe drive, so we are expecting to have a copy of Frogger on the Apple IIc drive. Okay, so I think the asterisk means it failed. However, if I'm assuming this drive has reading problems, maybe it's writing, but it can't verify it because it's a blind drive. So I have a theory, let the drive finish the process. But what I'm gonna do now, I'm gonna boot up from this floppy, which should have Frogger in it. Let's try that. And would you look at that? So the Apple IIc drive is writing correctly. The head obviously is moving correctly because it's capable of writing, but it looks like it's not capable of reading back. Now, as a test, I'll run Locksmith again. And what I'm gonna do now, I'm gonna do a copy from the Apple IIc onto the Apple IIe drive on a different floppy, of course. So I'm expecting to get Frogger on this drive, but if that is not reading, it won't work. Let's try that. From 2 to 1. Aha, as you can see, the drive cannot read. Something happened with the reading function, but it's not the read amplifier. Okay. This is very interesting. Well, first of all, because the drive couldn't write before and now it can't read. But the thing is, I'm not sure it's a mechanical alignment issue. Because if that was the issue, the diskette created on this floppy drive like a minute ago, the Frogger, wouldn't have worked on this floppy drive. It would have failed if it was completely out of alignment. But this looks like it can write correctly because this Apple IIe drive can read it, but it can't read its own diskette. Now, I did check the speed of the drive off camera. My tachometer said 296, so that hasn't changed, and we can't check the speed of the drive now because the drive is unable to read itself. So I'll have to study a bit the schematics and see what can cause a reading issue, but not a writing issue. And knowing that it's not an issue with the reading amplifier. I've now removed the logic board of the floppy drive, just to have a look at the stepper motor, see if there's anything that rings the bell or anything. I found this problem, let's call it a way, on my Apple IIe drives as well. Now that's a stepper motor which is driving the head. There is this metal band which goes all around here, actually a ring, and it basically acts like a belt, and it's attached to the stepper motor through the screw here and to the head carriage through this black whatever that is. Now the role of this carriage here on the left is to basically apply some tension so that the belt is always under tension, and there's a spring in here as you can see. But what I found with this design is that because the carriage is only attached to the track on one end, it tends to bind. So let me see if I can show you. Now if I move this direction and I leave it, as you can see, this is not going back. And now the metal belt is completely loose, so it wouldn't work now. It would have a massive mechanical play. And all I need to do is basically apply some pressure here, and that clicks into place. So what I'd like to do now is to just clean this part under, well, basically where the carriage of this pulley is attached to the track itself, add some lubricant, and hopefully that will improve a bit. But to be honest, to me, this is pretty bad design. Okay, I've decided to go with a little bit of grease rather than oil, because I think I've noticed there's no sleeve in here, so it's plastic on metal. I wanted to use something which is plastic friendly, and I think it doesn't get stuck anymore. It's still a horrible design, but at least it doesn't get stuck anymore. At this point, I reassembled the drive and tested it, but unfortunately that did not change anything. Well, at least the mechanism is working better now. Now, speaking of Apple computers, I've been thinking of reviving these Macintosh SE 30 motherboard. Now, the board is beyond repair as it was damaged, pretty badly damaged by a battery leak. But the whole motherboard has been reverse engineered, and Gerber files are available for a brand new PCB to be manufactured. Now, if I ever decided to go on with this project, my supplier of choice would be PCBWay. I've used PCBWay on this channel for a few of my projects, and I've never been disappointed by the product quality and also the customer service. So thank you PCBWay for helping the channel and also for providing quality products. If you'd like to see this project on this channel, why don't you leave a comment down below, and it might happen at some point. Okay, so we know that this drive can write, but it can't read. So the next question is going to be, is it like not reading at all? Or is it reading something with which the computer can't interpret, can't understand? Now, what I'm going to do, I'm going to test point 1. Test point 1 is the output of the reading circuitry of the drive. It's the polished version, so it's like the digitalized version. It should look nice on the oscilloscope. And it's connected to the same test point 1 on this drive. Reason is it's a bus, so there is a buffer before test point 1, so the drives will never talk at the same time on the buffer. It's going to be one drive first and the other one afterwards, which is great, because then on the oscilloscope I can compare the signal coming from this drive and the signal coming from this drive basically on the same screen at the same time. So here I've got Locksmith running, so what I'm going to do, to be honest, I just need to do a fast copy, and it doesn't matter which way I'm going, because again, even when it's writing, it's also verifying. That's why I was failing earlier on. I'm going to copy Locksmith onto this random disk, and I'll explain you what happens on the oscilloscope. So let's start a copy now. So that's the Apple IIe drive, so that's how the signal should be. And this is the Apple IIc drive, which shows you how the signal is on the Apple IIc. If I'm looking at just the waveform, it's not any different than the one from the Apple IIe, which will come back now. It's exactly the same. And it'll finish now, so I'll start it again. So that's the Apple IIe. You can ignore that overshoot at the bottom of the trace. That's my very long ground lead, which is connected to only one of the drives. But the amplitude and the length of the signal is exactly the same. This is IIc, this is IIe. As you can see, it's absolutely identical. So this is telling me that this drive is reading something. It's just the computer doesn't know what to do with that data. It's garbage. It's completely garbage. Now, we know that the reading amplifier works, and there's really not much in between the heads and the output of the drive itself. Now, if I'm looking here at the schematics, you can see that these are the heads. That's the reading amplifier. There's some passive components. That continues in the reading amplifier, for whatever reason is split in two, but it's the same IC. That's the output of the reading amplifier. This is the polished amplified signal, the one that we observed on the oscilloscope. Then this is going through a buffer. It's just a gate. Whenever you have the enabled pin, high, low actually, then the signal goes through the buffer. That's it. And then that's it. It goes back to the computer. There's nothing else. Now, obviously, there is some adjustments here. Well, there are some passive components, obviously, and there's some adjustments. One is called the threshold, one is called the pulse width duration. Now, I kind of struggle to believe that this drive has got so misaligned that it can write perfectly, and it can also be read by another drive, but it can't read like at all. But to be honest, I'm not familiar with these things, and I know that a couple of trimmers here to adjust the signal on the reading head, not on the writing. The writing, there's no adjustment. Now, when I started working on this drive, I did notice that the left hand side trimmer is factory sealed, the right hand side is not. Let me see if I can show you. You might be able to see that the blue sealant or whatever that is cracked. But to be honest, it was cracked before and I noticed it, but the drive was working. When I removed the faceplate, I had a feeling that I touched that trimmer by mistake, but I went back to some footage. If I did, it's minimum. And I don't know, I kind of struggle to believe that turning this thing like 1 degree, which is something I can't see on a picture or on a video, is causing all this trouble. That being said, it's a possibility. All the procedures I found online to actually calibrate these drives do require the usage of what is called an alignment diskette. The alignment diskette was basically created by a perfectly aligned machine at the factory and shipped with some alignment software. The idea is you are calibrating your drive so it reads exactly as the calibrated machine at the factory. Now, that calibrated disk has some test patterns on some tracks. So what you're doing, you are selecting, I don't know, track number 1, it has 125 kilohertz, track number 2, it has something else, and so on and so forth. Without that disk, it's pretty complicated, my understanding is, to do this. And honestly, I can't really find much that tells me how to do these things. Now, I actually found one procedure which doesn't use the calibrated diskette, but it's using something which is self-written. So basically there is a software which is writing some test patterns on the tracks, and then it reads them back so I can adjust the drive looking at the oscilloscope and looking at some tracks. Now, the procedure I found uses these disk alignment aid, and the first test I'd like to try is the amplitude test. So let's skip to amplitude. The software is now writing a pattern on the disk, and it will be reading it back in a second. On screen now there is a waveform. It's supposed to be 125 kHz, and with an amplitude of at least 150 millivolts. Let's measure the frequency first, and it's exactly 125 kHz, so that is great. The amplitude is around 230 millivolts, so that is also great. The next step is to move the probe onto a different test point, and I'm expecting to see the exact same signal. Here it is, and yes, it's the same frequency and the same amplitude. This test is telling me something important. The drive can read, and it's reading what it's supposed to be reading, so that is a great start. Now, obviously, after this stage, there is a stage where the electronics has to translate what is being read into digital data, and I think this is where these two adjustments come into play, because especially the one called threshold, I think is the one which is deciding which one is 0 and which one is 1, so maybe a wildly misaligned threshold will thrash the signal basically, but I don't know. Let's go ahead. So the test I'm running now is basically to adjust what is called the comparator offset. Don't ask me what that is. But basically I've run the amplitude test again on the same drive, but I'm connected to a different test point, and I'm supposed to see these on my scope. And basically it says to adjust one of these two trimmers in order to have the signal with this timing. So the whole signal is maximum 4 milliseconds, and the distance between this part here and this part here is going to be between 2.5 and 3 milliseconds. Now, if I'm looking here at the scope, it looks like the raising part is actually 4 milliseconds, so it's a bit too long. And the whole signal here, which is jittering, is fine. It's 7.8. It's supposed to be maximum 4 milliseconds, so that's like twice as wide, which is great. It's nice to find something that doesn't work on this drive. So the manual is actually telling me to adjust the potentiometer, which has not been touched. To be honest, considering that this drive doesn't work, I think it doesn't hurt to break the ceiling, the factory ceiling, and just try and adjust it and see what happens. So I'm looking at this thing, at the scope, and I need a maximum of 3. So this has to be like here. So let's try and touch its adjustments and see what it does. Oh, wow. Okay. Yeah, you can see that is changing. I'm moving it a bit back and forth to like clean the contact a bit. And I will have to... I would say that that's probably fine. It needs to be maximum 3. Now we are at 276, which is perfectly fine. And the whole signal is 3.9, which is perfectly fine as well. So this looks like it's back within specification. So that's great. So the next step is to check on a different pin, which is pin 7, and observe this waveform that you see on screen, and basically adjust the trim, which is the one that was touched at some point, to basically reduce the amount of jitter on the sides of the picture. So let me see what this adjustment does. You can see the jitter increases, and I can take it to a point where it's minimized and then it gets increases again. So let's, I would say, yeah, that's it. It's more or less where it was before. So surprisingly, that's not the one that needed adjustment, it was that one. Now, I'm not sure whether it's required, but I think I'll go back to the previous test point and just make sure that my waveform is still the same. Yes, it is still the same. Perfect. I think that concludes the adjustment. So I would be extremely curious now to see whether this works or if there's any difference whatsoever. Okay, I'm back on Locksmith. The easiest test would be just to make a copy and see if it works. I'm not optimistic, to be honest. So I'll try this copy from the Apple IIe drive to the Apple IIc drive. And again, the Apple IIc will write and verify. So if it can't read, that would be it. Now. So that's the Apple IIc reading, sorry, IIe reading, and that's the C. Now, hey, it's working! It's not failing anymore, look at that! Oh, seriously? Oh my gosh, I didn't touch that adjustment. Oh wow, I want to try the other way around. Let's make a copy of Frogger. Oh, this is so exciting! And then we can check whether it's working. It's reading fine, look at that! It's actually working! Oh my gosh, I spent like a day and a half after that. Look at that, it works! And now it's time to see if the drive can boot. Okay, ready to go? 3, 2, 1, go. It's working! Oh my gosh, a day and a half. A day and a half after this thing, it's freaking working! Wow, that's amazing. Actually, this drive was written by this floppy. I want to try something else, like XPS. Oh yes, let's try XPS and let's check everything. Well, it's working. Yeah, there's one speed error, but again, because I set the speed a bit lower than the software is expecting, but it's only failed once, which means probably it's borderline. It's probably 298 something, which is probably where it should be. Amazing. This is absolutely amazing. Yeah, the speed is totally fine, 298 point something. XPS is expecting probably 299 as a minimum, something like that. I don't care, it's fine, it's working! Well, the next and final step is going to be the keyboard. As you can see, this membrane inside, it's got all wavy and it's just preventing the keys from being pushed. You can clearly see that here. So I think I'll have to remove all the keycaps, which is going to be fun, and at least remove these membranes and see if I can improve the situation here. So this is what I'm talking about. There's one rubber membrane on top, plus another very stiff rubber membrane at the bottom. Now, I appreciate this is not the Alps keyboard, so this is never going to be exceptional, but I'm sure it's going to be so much better without these two things. I won't use this Apple IIc when it's raining, I promise. There you go. But yeah, these keys are supposed not to be the best. Let me show you why. So basically they have these kind of, I don't want to call them, they're not latches, but these are supposed to give some tactile, if I'm saying that right, feedback. So you see when I'm pushing this, it's actually squeezing the spring. Now, some of this get a bit stiff over time and can get a bit stuck. So it feels like you have to push the key because it doesn't go down. But this, to be honest, feels fine. It needs a little bit of lubricant. Yeah, I can see it's catching a bit sometime. But that's not bad. It's so much better than there was a moment ago. Now, this one, for example, is not catching at all. Hopefully you can see that. While if you check this one, this is catching a bit. But I think a little bit of lubricant will make things much, much better. I started by cleaning the keys with some isopropyl alcohol. The idea was to remove any dirt and residues from the plastic. Then I apply some plastic safe grease. This is the same super lube I used to lubricate the Macintosh floppy drive gears. I used a number of tools here: small screwdrivers, tweezers and cotton buds. I've also adjusted some of the springs so no keys would bind, while retaining a bit of that tactile feeling that was intended by the designers. And finally, I cleaned each key one by one and put them back on the keyboard. And it's back together. The keyboard is incredibly better. It feels like a cheap mechanical keyboard, to be honest, but it's so much better. I mean, previously it was absolutely unusable. It's actually not bad, I have to say. Well, we finally got to the end of this video. I was totally not expecting 4 different faults in this machine, but I really enjoyed fixing them all, finding them all. Actually, I feel that I was actually lucky that the drive didn't have both faults in the first place, because it would have been pretty complicated to diagnose a drive which doesn't read and doesn't write, and I think I wouldn't have assumed 2 different faults on the same drive. So, you know, happy days. I really love this machine. It's so compact, it's so nice. The drive is so quiet, it sounds so good, and the keyboard is so much better than it was before with those horrible membranes under them. So as I said, I really enjoyed fixing this machine. I hope you enjoyed the video too. If you did, I would really appreciate if you could hit the like button down below, and also consider subscribing to this channel if you like this kind of things. For now, I wish you a great day, thanks for watching, and I hope to see you again here soon for my next videos on this channel. Thank you very much, and goodbye. Bye.